So in the given problem is given a DC series motor which is having a resistance of 1 ohms which drives a fan load. So as we know, fan load means the torque varies as a square of speed. So and also is given at 220 volts the fan runs at 350 rpm and takes a current of 25 amperes. Now he wanted to increase the speed to 500 rpm by increasing the voltage. So he is asking how much voltage is necessary in order to increase speed from 350 to 500 rpm. So in a fan load the torque is proportional to speed square, and we know that the torque is proportional to, in a DC machine, flux into armature current. Since it is a series machine, flux is proportional to armature current, so that means torque is proportional to Ia square or I square. So from these two equations, speed square is proportional to I square or I is proportional to speed. So this implies I can find out how much current it is taking. So Ia2 by Ia1 equal to N2 by N1. So Ia2 equal to Ia1 is 25, N2 he wanted to increase the speed to 500 rpm from 350 rpm. So if you calculate this, you will get 35.71 amperes. Now we will see how the back EMF changes, because back EMF plus drop is nothing but the supply voltage. So we know that the back EMF in a DC machine is proportional to speed into flux. EB is proportional to speed into current in series machine. So first you calculate EB1. EB1 is nothing but 220 minus the current which is drawn is 25. The current resistance is 1 ohm. So this is 220 minus 25. So this is equal to 195 volts. Similarly EB2 equal to 220 minus Ia2 into 1. So this is 220 minus Ia2 is nothing but 35.71 into 1. So this is EB2. Now EB2 by EB1 is equal to N2 by N1. So N2 is 500 by N1 is 350 and I2 is 35.71 by I1 is 25 amperes, right? Now this back EMF we can also write in terms of supply voltage. So we can also write in terms of supply voltage. I think we did mistake here somewhere. Yeah, when the back EMF is EB2, the supply voltage is not 220 volts. No, this is what he is asking. This is V. When the back EMF is this much, this is the current, right? Now he is asking the supply voltage V only. So this is not 220. So this is equal to, this is also V. So back EMF is nothing but V minus, this is 35.71 into 1. So that means 35.71 by back EMF 1 is 195. This is equal to 500 by 350 into 35.71 by 25. So if you simplify this, you will get a voltage which is the supply voltage required to raise the speed to 500 rpm is 433.7 volts. We'll see the options. Yeah, option D is the right answer.